Hi there, my name is Toby, and in this lecture I want to offer an alternative explanation for the double slit experiment, which is the foundation of quantum mechanics. And in fact what I'm offering is an alternative science. There's another science that has been hidden from us and actively dismissed, and that is the science of ether. This was Tesla's science, but Tesla was not alone. There were a lot of great field theory experts that worked together, and they all believed in the ether. Now, after the Second World War, that was dismissed, and we got Einstein and quantum mechanics. Now, this all boils down to there's only ever been two theories about the universe. One theory is atomism, everything is particles, but we now have to answer the question as what is a particle, what is matter? And then the other theory is ether, fields. There's a grand unified field, and that's pure fluid. So it's not particles, it's a different type of a thing. And see, I do believe ether science is much better. A grand unified field of ether provides a better science. It's more comprehensive, and it will solve all the problems that quantum mechanics is struggling with. You see, quantum mechanics is only going to get so far because it's based on a false assumption. It's based on the false assumption of materialism. But it's been dismissed. You see, ether has been dismissed. Any modern scientist now will laugh at you if you talk about ether. But Tesla, the most famous protagonist in ether science, he did not like Einstein. He did not like quantum mechanics. He was very much against it. He thought quantum mechanics and relativity were nonsense. And he was very upset by this. And indeed, I studied physics. I have a degree in physics, and I nearly did a PhD in theoretical physics. And one of my professors at university was one of the top guys in quantum gravity in the world. And he started his lectures by saying this. He said, there are these two theories. On the one hand, we've got general relativity, Einstein's theory of gravity, and on the other side, we've got quantum mechanics. But these two theories don't mix. They don't work together. We can't make the equations work together. So that means one of these theories must be wrong. Or both of these theories must be wrong. It has to, that's logic. So this was a top professor, mainstream professor in quantum gravity, and he's saying we cannot make this work. Now the thing is, they don't want to go back to the drawing board. They won't go back and look at ether again, but they should. You see, if all the time, money, effort, and brilliant minds that are thinking about quantum mechanics would go and start thinking about ether, it's a totally different philosophy, a totally different way of looking at the universe. They would find the answers they are looking for. Because modern science is actually looking for that. They want the grand unified field. They're all looking for it. That's what quantum gravity is. They are trying to find the grand unified field theory that would connect gravity and quantum mechanics, but they can't find it. But it's right under their nose, because ether is that. That is the grand unified field. The only trouble is they have to acknowledge metaphysics, and they don't want to acknowledge metaphysics. It's pure, so quantum mechanics is still purely materialism. And that's why it's so mysterious, it's so complicated, and they've got so many fantastic ideas. Quantum entanglement, instantaneous action at a distance, dark matter, dark energy, quantum flux. You see, all of these become mysterious. What the hell are these? And they find a new one every time. But all of these things can be explained with ether science very simply and very easily and immediately. But they don't want to think about that. And in fact, you see, even Einstein's relativity is based on an assumption. It's based on the assumption of space-time. There is a thing called space, and there is a thing called time, and we can bend them. But Tesla did not agree with this. He was very upset with Einstein. He wrote to him very often. And basically he's saying there is no such thing as space, and there is no such thing as time. These are not things in themselves. So they cannot have any properties. You can't bend them. You can't do anything with them. You see, space is like a shadow. It's only a shadow. But you cannot do anything with a shadow. Yeah, a shadow is a thing, but it's a shadow. You can't do anything with a shadow. It's an effect of something else. It's not a thing in its own right. So space is the shadow of the field. That's the way you could look at it. My point being is ether science has been completely overlooked and we need to look at it again. And on this channel I'm trying to share my ideas about this and start us thinking about it. And again, but it's just me, I'm all by myself saying what I am thinking about. So these are only my ideas, my theories, but I'm backed up by a guy called Ken Wheeler. So I thoroughly recommend his channel. I'll leave links below to him. An extremely clever guy, has read all of Tesla's work and has written books on magnetism. So he backs up a lot of what I'm saying, and as does Taoist philosophy, because it's very interesting. When you get involved with ether and metaphysics, it's very similar to Taoist philosophy. But let's have a look at the double slit experiment, because what could really be going on? The double slit experiment, let's take you through it first of all, so you know what it was. So it works like this. You have a source of light here, a candle. Let's say you've got a candle. But then you need a lens. You have to have a lens. Very important. You need to focus this light into a lens, so you've got a beam of light. Then the beam of light goes through two little slits, two apertures. So, and then what happens is at the back of the wall here, you've got some material that the light can land on. And what you get, when you shine a light through here, you get an interference pattern. And at the end here, you get different lines. Lines appear. But we know what this is. This is field theory. If light is a wave, I'll come to that in a minute, but then of course the wave comes through here, splits into two waves, and now what you have here is an interference pattern of two waves. And the interference, and what's hitting the wall here are, I didn't do that very well, but are the nodes of constructive interference. Let's do it again here. When you've got two patterns like this, waves building up, what you get, where they cross over, these are called the nodes of constructive interference. And here where you've got an empty space, these are called nodes of destructive interference. And what's hitting the wall here, this photographic material, are the nodes of constructive interference. So that's all well and good. And out of interest, you can do this with water. If you have a wave of water coming, you can have two apertures like this. So imagine here's the wave, ripples of water coming. They hit two apertures, and then you can see this. Each one will have a wave ripple coming out, and this one will have one like this. And then you'll see the interference pattern of the waves forming. And the interference pattern hits the back wall. So all well and good. Now, the thing is, this gets interesting when you turn this light source down. It gets smaller and smaller and smaller. So how can you get a smallest light source is going to be a single atom. A single atom. So again, this is what quantum mechanics says. A single atom will emit a photon. So they're calling this a photon, a particle of light, a parcel of a waveform. They also call it the waveform, but essentially they're calling it a particle, a thing in its own right. So this particle gets fired to these two beams, but it's one particle. So it has to go through only one side, and if it only goes through one of these slits, it's just going to land in a straight line at one spot. But it doesn't. When you fire this particle, it's like the particle splits into two, it goes through this interference pattern, and then it will still land, it will land in one spot, only one spot, but it will land in a place where this interference pattern should be. And if you do this millions and millions of times, you get lots and lots of spots building up, and all the spots end up in exactly the same interference pattern. So they're saying, well, this one particle must split into two somehow, go through this process, but then it lands in one spot only. So how does it know where to land? So this is the mystery. This is the mystery that quantum mechanics is trying to solve. And I want to offer a much simpler solution. And just to cut to the chase, my simple solution is this. This is not a particle. This is still a pure fluid energy. It's pure fluid. So this will still have to be focused. This will still, it's still going to pass, pass through both of these slits. It's still going to have this interference pattern. But this is such a low quantity of energy. It's so low that now only the occasional node of interference will land. You see, this material at the back has to register, has to have enough energy on it to register a dot. if not enough energy lands on it, it won't register it. So because we've gone down to a tiny amount of energy, this requires just enough energy to stimulate the photographic material, and only one little node of this interference pattern has to align. It has to line up with the atom in the material to stimulate the atom to make a point. In other words, the atoms on this material require a particular amount of energy to activate, and only if they get that much energy will they activate. So there's not much energy coming through here. So only one, by chance, you see, and it's all by chance, because the next time the point's over here. The next time the point's over here, it's over there. So the same thing is happening, but one of these nodes of interference, one of these points, one of these nodes of interference just happens to coincide with one of the atoms in the material at any given time you fire one of these through. So there's not really any puzzle here. There's not really any puzzle here if you look at it like that. But of course the puzzle arises because you're assuming this is a particle. How does it do that? And again, you should understand that it's very difficult to actually fire a single photon. You have to do this with a beam, a very low beam. So again, I think, and again I'm not sure, but I think it won't happen every time. Even if you could, let's say theoretically you could control a single photon. Of course they call this a photon. And that fires through and it will land. But I would say it won't always land. Sometimes you'll fire a photon, but nothing may happen. Again, that's my theory. That's my theory. And sometimes you fire a photon and bop, you've got a spot. Because there's an element of chance. You see, this is still a pure fluid, a tiny amount is focused in, goes through this, but there's such a slight amount, it has to, it's the chance of one of these nodes hitting the back wall. So now, how would I explain this in terms of ether? You see, quantum mechanics says light is a particle and light is a wave. The problem is you can't say either of those things. If you say light is a particle, you have to define what a particle is. What is it? This is very deep philosophy. It's asking the question, what is matter? What is material existence? What is it? Well, it's a substance. Yeah, but what's a substance? You've got a big problem if you say what a particle. You have to define what a particle is. Then if you say it's a wave, well, you can't say it's a wave either, because a wave is not a thing. You see, this is a wave, but this is a wave of my pen. A wave is an action. You see, you can say a wave of water. A wave of water. You see, what is waving? The water is waving. If you're going to say light is a wave, you have to say, well, what is waving? What is it a wave in? Well, light is a wave in the ether. It has to be. It has to be in something. Now, again, let's look at a wave in water. This is another thing to understand. In a wave, let's say water here, you've got a tsunami, right? There's a tsunami traveling along. Right, there's a tsunami. But the water is not traveling. Nothing is traveling. This is a disturbance. You see, the water is just going up and down. And this disturbance is moving along. The water is just going up and down. There's no transfer of water moving along. The disturbance of the water is moving along. And here at the end, the disturbance hits the shore. So that's a very, very important distinction. Now, Tesla said this. He said light can be nothing more than a sound wave in the ether. In other words, it's a disturbance in the ether, and that disturbance is propagating away. And there's no speed. It's not a speed of light because nothing is traveling. Remember, this wave, this tsunami is not traveling. The water is not traveling. It's still in the same place. It's just going up and down. The water has been disturbed and the disturbance is traveling. Same with light. Nothing is traveling. The ether has been disturbed and the disturbance is traveling. So the speed of light is the what you call hysteresis of the ether, the resistance of the ether against itself. See, for example, the speed of this tsunami might be, I don't know, 100 miles an hour. But that will be determined by the surface tension of the water, the weight or the density of the water, and so that determines the speed or the propagation of the disturbance in the water. So the speed of light is really the resistance of the ether against itself, the rate of propagation of a disturbance in the ether. And you can tell that in light as well, because look, again, another big problem to ask anyone in quantum mechanics, in modern science. You get light, and we know light travels in a vacuum at speed c. Then you get, say, a lump of glass. When it hits a lump of glass, it slows down. So now you've got refraction. So now, because it's passing through glass, you see now here, it's passing through glass, the medium has changed, so the speed of light has changed. But when it comes out of the glass again, it goes back to c. It's gone back again. Now again, if this was something travelling, a photon travelling along, the photon loses some energy, it slows down. If it then comes out of the glass again, how does it speed up? Can't speed up, it will now continue being slow. But it doesn't, it speeds up again. That's because nothing is travelling. Got to understand it. Here's an atom, and again, here's an atom. We think, oh, a photon is released, a particle flies out. It's not like that. An atom has got various harmonics, energy states. When the energy state drops, a certain fixed quantity of energy releases. It's a fixed quantity. It's always the same. That's why we're getting confused as a particle. But it's a fixed quantity of pure fluid energy. So when an atom changes its energy state, it creates a disturbance. So it doesn't come out like this, it will come out all around. It's like a wave of disturbance. And this disturbance, this propagates through the ether. And when the disturbance reaches the glass, it's now got to propagate through the glass. So this is a different medium, so it propagates at a slower rate. But now the medium's changed again, and the propagation can speed up again. You see? It's not anything travelling, it's a disturbance that is travelling. A different distinction. You see, ether physics will explain everything simpler, more immediately, more directly, and of course it needs research. Of course, at the moment it's just little old me on this channel saying my ideas. Now, I have thought about this for all my life. I think about this, so I've got to share what I'm thinking about. But of course, these are my own theories. These are just my own theories. So again, I welcome any questions or comments, because I want to keep improving these theories. But I do believe ether science is beautifully simple, and there should be no paradoxes in the universe. And it should be, okay, let's have this final discussion about a wave and a particle. Okay, let's fix it though. Let me define this a bit better. So I'm going to define what a wave is. A wave, or light, is a disturbance in the ether. So it's a propagating disturbance in the ether. So I've now defined what it is. Now I'm going to define what a particle is. There is a particle, there is one, and a particle is a standing wave of the ether. In other words, if there's a disturbance created in the ether, there we go, we've got a propagating disturbance, but you can have this at any frequency. So if you go to higher and higher frequency, there's more and more energy. So like if you go to gamma, at the moment we've got microwave radiation. That's got a higher frequency, so it's more damaging. You go up to gamma radiation, it's such higher frequency, it's even more powerful. That is a bit like being bombarded with particles. Bang, 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 gamma radiation. So the higher the frequency, the more like a particle it will become. But again, at a very high frequency, super high frequency, way above gamma radiation, what happens is you will create a particle, a loop. The wave will loop over itself, and you will have a self-sustaining disturbance of the ether, a self-sustaining wave. And that is a particle. But you can only have one, because there's only one ether, there's only one wave that can appear in the ether, there's only one way of disturbing the ether, so there's only one way of creating a self-sustaining disturbance of the ether, which is this, and this is called a neutron. And this is proven, you can check out, I'll leave the links below to Ken Wheeler's channel below, he talks about this, but black holes are emitting neutrons, very powerful stars are emitting neutrons, so super high energy, neutrons will come out, so it's super high frequency light. Plus they've done an experiment now where they've fired two powerful lasers at each other. So two powerful lasers, super high frequency light, and neutrons were produced. Matter will be produced. So super high frequency light will create a self-sustaining standing wave, which is a neutron. And there is only one. There's only one particle, but that's all you need. You don't need any more. Don't need any more. You can have arbitrary packets of energy, but they're not really particles. They're not self-sustaining. So they just disappear. They return back. There's only one self-sustaining particle, which is a neutron, and even that is slightly unstable. It has to be held together with a proton and an electron. Now, a proton is the same as a neutron. It's a more stable version of a neutron. I'll talk about this in my lecture series, but an electron is not a particle. Electron is a bit of pure fluid energy that balances a proton. And all matter can build up from this. So that's what I talk about in my lecture series, Magickal Science, which is my attempt to build a simple model of the universe from scratch, using philosophy and logic and a certain amount of understanding of physics that I have. So please do give me a chance, have a listen to my lecture series if this interests you. And thank you so much for listening. I really do appreciate it. And I look forward to seeing you in any of these other videos here.